So I'm Fred Kim, and I'm here with Paul Roberts, and both of us are product owners for nCode. I'm more in charge of GlyphWorks and VibeSys, and Paul will cover the new stuff in DesignLife. So this presentation is indeed about what's coming up in nCode 2019. So before we start, a little agenda, so a little introduction on who we are, just a few slides. Then the highlights of what's new in 2019. Then we'll go more into GlyphWorks, then VibeSys, and then we'll end up with DesignLife. So Prancia, the idea is that we have a unique solutions for reliability and durability, and the idea is to deliver a more complete lifecycle solution. So we've got software, services, and solutions, and the idea is to convert engineering data, tables of data or measured data or calculated values into actionable information. And the idea is to improve the efficiency, simulation, reliability, safety, durability, etc. So this is done through two software brands, the nCode brand and the ReliaSoft brand. This is done also through training, education, so training classes and theory classes, hands-on on software, etc. And also services. We got a material lab for characterizing your materials, or we have solutions for design and test, and for asset management. So that's Prancia. So I mentioned the software brands with a little bit more details. So we have here the ReliaSoft tools on the left-hand side and middle of the screen, and on the right-hand side the nCode. So if you look at the left column, it contains tools for reliability analysis, typically failure data analysis with Weibull++ or Alta, test planning with those tools too, and we got system modeling using BlockSim, Reno, etc. In the middle, we have tools for the reliability management. So here we want to manage risks, we want to manage maintenance, we want to manage actions related to maintenance, etc. Now on the right-hand side, we got the nCode tools for durability this time, for the analysis of measured signals, for the vibration and acoustics analysis of measured signals, etc. The last one, Akira, offers a web portal and enables you to access the measured data in a shared area, and the various tools with secure access, everything's controlled, etc. Today, in this presentation, we will concentrate on those three tools here. So DesignLife, which Paul will cover, GlyphWorks and VibeSys, which we'll cover now. So the highlights in terms of nCode products, in terms of priorities. So in this new version, you'll see that we've added quite a few features, enhancements to do with test and CAE correlation. So the idea is to compare what you measured with what you've simulated using finite element tools. We've got now the Modal Assurance Criterion. That's a new glyph that I'm going to present in a minute, enabling you to compare the mode shapes that you've measured, that you've observed using sensors, with the mode shapes that you obtained using FEA. Fatigue of welds is constant development. So we got Whole Life, which is a new, brand new method of ours, right? We released it last year, and we will present it at the next SAE conference in Detroit. Vibration fatigue is another topic we're working on actively. So we want to support the frequency domain fatigue methodology throughout the various glyphs that we have in DesignLife. So also for welds in practice. General enhancements, we still although we develop new stuff in there, we're very much listening to customer requests, and we keep making sure our software is has a good level of usability and is as performant as it can. Technology initiatives, so we got a technology team. They're looking at fatigue methodology for additive manufacturing components or for continuous fiber composite material, durability of those materials. So all this is now available in nCode 2019, and it's available for download as we speak. So check out our website. If you go into the support portal of HBM Princia, you'll be guided to this download area. Akira, which I mentioned, Akira 2019 will also be released soon. So stay tuned, and you'll know more about Akira probably in March, and we'll launch Akira and a number of new features in there in the Detroit user group meeting end of April. But Alex will tell us more about this at the end of this presentation. So let's start with GlyphWorks now. So what's new in GlyphWorks 2019? First, in the XY display glyph, we've enhanced the use of cursors, where we've added additional features for the use of cursors. So now you can have your cursors displayed as those little crosses or the mark types, right? So it's a different way of positioning cursors on the curves, and you have an option to hide the cursor values, the X value, the Y values, so that you just have this little incremental number next to your cursor. And if you want to see the values, you can output them in the cursor table or in the output pipe, and add a table in your report, for instance, with the values. So that's a different way of using cursors, especially when you've got a number of cursors in a small area. You want them to be slicker and look rather like this, right? Still with XY displays, what sits on the top of each display is now more controllable. We've got this title source drop-down menu, and you can control what information sits there. So this is simple stuff, but required by many of our customers who are looking at data, whether it's the raw data that's been collected, or if it's it can be also the results, like here spectra or filtered signals, or who knows, So viewing data is quite important. It's an important activity, and we want to make it as easy as possible. And the idea is to get to conclusions faster and easier from displaying data. Now, in terms of usability, we've added the zoom option and the pan option in the workspace. So where you're connecting all those glyphs, right? The main workspace in the nCode suite of tools, but also in the Studio page. So Studio is this tool that enables you to create reports, live reports, really slick. So by using the control button and the right mouse click, you can pan like this one, like here, right? You can move your workspace or your Studio page around, and using control and the middle mouse button, you can zoom in or out. So it's a very easy way to navigate through your workspace or your Studio page. So again, faster and easier use of the software. In terms of file formats, we got new file formats. We got the BNK Connect file format that we can read. So that's the BKC file format. We used to have, we still have other file formats from BNK. We support the UNV file formats as well from BNK. That's the new BKC file format that we now support in GlyphWorks, and of course VibeSys and DesignLife. We got the Dewitron R3 DMD files as well that we can read natively. In terms of the file formats that we currently read and we enhanced, we have more data that's extracted from SIE files. So if you're using a SOMAT data acquisition system, This one produces SIE files. Now you have access to more metadata, especially when it comes to figuring out what setup file was used and things like that. Or Kiowa is another data acquisition system, and we've upgraded to the latest version of their file formats. So all this to process measured data regardless of where the data comes from. So we're hardware agnostic, and we like that. So for those of you who are not familiar with nCode products, we read like, I don't know, 40 different file formats natively, binary file formats typically. That's something we're really proud of, and we will continue making sure we're not tied, or we say we're completely agnostic again. No matter where the data comes from, we can read it. Now, in nCode, you can use Python to add new capabilities, new algorithms, or proprietary algorithms. You can augment, if you like, the palette of glyphs, the features that's in there with your own things. So far, we supported Python 2.7, and now we support also Python 3.6. So you get a new preference in nCode 2019, which sets which Python version you want the software to use. Now, be aware that from next year, actually, Python 2 will no longer be supported by the Python community. So we will also only support Python 3 from nCode 2020. So if you want to know more about the difference between Python 2.7 and Python 3, we've got a manual called Using Python in nCode with examples showing that the syntax difference. But it's, for those of you who are not familiar with Python 3, no worries. It's not a different language. That there, very few changes in practice. So it's probably a very good idea for you to plan the migration from your script in Python 2.7 into Python 3.6. There are different ways of doing that. There are libraries out there or software that do that for you. But again, trying to find some information, and you'll see that there are only a limited places where changes need to be made. So Python, again, is a fantastic way of adding whatever algorithm you want to put into the software, and we make sure we are up to date with the current versions of Python. Now, in nCode 2019, we've got more capabilities with Rainflow cycle counting. For those of you who are familiar with the Rainflow module that still sits on the left-hand side of your nCode desktop, now the options in there are available as glyphs. So we're talking a Rainflow extrapolation. So there's a glyph for that, and it can extrapolate a measured rainflow in terms of its duration or in severity, if you like, in percentile. So if you've measured, I don't know, 10 hours worth of operational, usage data, and you end up with a rainflow that represents that in terms of the cycles, the fatigue cycles, you can extrapolate that to 10,000 hours, or large multiples of that duration, measurement duration, and it uses some statistical techniques that you will see that cycles that you have not measured will appear, simply because statistically speaking, the longer you measure, the more chances you have to see those extreme events, extreme cycles, right? So it can be very useful to extrapolate a rainflow and therefore predict, or you can take into account the variability and things like that of your measurement without having to measure that long. So it's quite interesting. Now, if you want to sum up rainflows that have not the same bin sizes, number of bins, etc., you typically can't. So we've got this new Rainflow Rebeaning option inside of the histogram manipulation glyph. So you can rebin a rainflow or a set of rainflows such that they're now represented in the same bins, and therefore they can be summed or combined, say. So the idea is to extrapolate and combine usage information in a very efficient Rainflow domain. So this Rainflow here can represent billions of data points, right? But in a Rainflow form, it's maybe a 64 by 64 matrix. So it's very, very efficient, yet it contains the fatigue information. Still to do with Rainflow cycle counting, once you have a Rainflow matrix, you can now find out a time series, a corresponding time series. So we've got a new Rainflow to time series glyph. It expects a from to or a range mean Rainflow histogram in input, and it'll generate a time series. And this time series, if you run it through the Rainflow glyph, you'll find out the same. You'll find the same Rainflow again, right? So this time series is reconstructed from the input Rainflow matrix, and the use of that, if you've got, if you want to, use this Rainflow as a loading information to a test rig or to some nonlinear, for instance, CAE, FEA calculations, well, you'll have somehow to turn it into time series. So we provide you with the way to do so. So that's the new Rainflow to time series glyph, and so it enables you to move from the Rainflow domain to the time domain. So that was it for GlyphWorks. If you want to know more, because there are more to it, there are the release notes that come with the release when you download it. So check out the release notes if you want to know all the things that all the new features. But those were the main ones. Now let's move on to VibeSys. So the main new feature in VibeSys is this new Modal Assurance Criterion, or MAC glyph. So this one enables you to compare the mode shapes between test and FEA typically. So that's its main use. So here, for instance, we obtain this histogram, and it's comparing mode shape 1, 2, 3, 4, 5 of the FE model. So after running my model finite element analysis with mode shape 1, 2, 3, 4, 5 that I've measured using accelerometers on the real equipment, right? And typically, wherever a tower here is very high, means that the corresponding mode shapes are very similar, if not identical, right? But very, very similar. The higher it is, the more similar they are. And if it's very low, the mode shapes do not correspond at all. So typically, what you're after is a diagonal histogram like this one, with very low values for the cross, for the non-diagonal terms, right? So this indicates that you've got a very good correlation between test and model, and therefore you can trust your finite element model, in terms of the boundary conditions, the mass distribution, things like that. You're fairly confident that you've captured the right mode shape. So at least they're very comparable to those that you've measured, that you've observed on your test rig or with your hammer, right? So that's the test CA correlation using the MAC matrix. It doesn't compare the natural frequencies, right? It just compares it compares. It's dedicated to the comparison of the mode shapes. Now, another use of the MAC is for identifying where those sensors, accelerometers, should be positioned on your FE. Where should you position your sensors on your component to correctly capture all the natural mode shapes, right? So you could do that in the CAE world by sticking virtual sensors and calculating what we call the AutoMac. So let me show that in the next slide. But again, the main use of the Mac Glyph is to really enhance your FE modeling by comparison, by comparing the mode shapes with what you've measured, and also by making sure, and we'll see that in a minute, that the sensors are positioned at the right places. So the question is, how do I make sure that I'm correctly capturing all the mode shapes of interest, right? So how many sensors should I use? Where should I position them? Those are regular, the usual questions that one may ask before doing a model test. So say we have this simple structure here, and we've run a model analysis in FEA, and we came up with those 6 modes. So you have an idea of the mode shapes that you expect to see in your test, right? So how to answer this question? The idea is to start by positioning sensors at places and directions that you think are make sense, say. And the idea is to make the auto Mac analysis. So what you want to do is see whether the off-diagonal terms are not too high. In this very case, you see that mode 5 and mode 1 are very close, if not identical. They've got a Mac value of 1. So you apparently don't have enough accelerometers, or at least those 3 accelerometers, uniaxial accelerometers, do not distinguish between mode 5 and 1, right? So let's add triaxial accelerometers now in different positions. In that case, the AutoMac matrix is much better, less of diagonal terms with high values, right? So this means that all the 6 modes are now captured without any ambiguity, right? Again, this AutoMac helps you optimizing the physical instrumentation to capture your modes in the frequency range of interest. I think that was it for GlyphWorks and VibeSys. I'll now pass the mic and the mouse to Paul for the DesignLife bit, and at the end of this presentation, we'll just recall you a few webinars that are coming up, and one of them will discuss further this Modal Assurance Criterion. So Paul, let me define you as presenter.
Thank you, Fred.
Yeah, you should be able to share your screen.
You seeing the screen, Fred?
Yes, I can. Well, it's going...
Wrong one.
I could see several of them, actually. That's much better.
Okay. Thanks, Fred. Right, so Fred's covered GlyphWorks and VibeSys, so I'm now going to cover the new things in DesignLife in 2019. Okay, so the first thing to mention is that there's a new load provider in DesignLife called the Rainflow load provider. So this is complementary to the GlyphWorks Rainflow, the time series Glyph, where if you've got a Rainflow, you can generate a time series which you then could use in a CAE analysis to do a nonlinear time step, for example. But this is more for if you've got a Rainflow and you want to use that as a single load input, you can use that directly now in DesignLife to scale your load. So in the same way as a time series is used, but using the Rainflow levels directly. So if you've got a linear FE and you want to do from Rainflow, this is probably the method to use, and probably a bit quicker than using time series. But if you want to do non-linear FE, then you have to do the Rainflow to time series Glyph and then use the time series directly. A couple of restrictions for this: you can only have one Rainflow matrix as an input. So you'll see the interfaces change slightly, so you can only select one load. But then that can be applied to multiple load cases from the FE. So you can only use one load, but you can apply it to multiple locations in your model. So that allows you to use directly a load-based Rainflow without the need to regenerate a time series if it's applicable and you've got a linear FE. Quite a lot of the modifications we've done in the last few versions have been directly to cover customer requests. One of the things that we were asked to put in initially as a prototype, which we did a few years ago, and now as a full method, is this new 4-parameter SN method. So that involves a new material type, as you'll see on the screen, and 4 parameters defined a curved SN curve, and a new method that appears in the drop-down list in the SN glyph as a 4-parameter type. This is a method defined in a DefStan 970, and it's basically the same methods, but using a more resolved curve. You get some extra parameters with that. You can switch between UTS and yield as the controlling factor in the mean stress correction method. And you can also add a mean stress exponent that gives you an intermediate method between the Goodman and Gerber that are the two main methods. So if your mean stress can be factored slightly to fit between those two methods. So a brand new SN method with a new material. That's part of our continued support for customer requests as additions to DesignLife. So one of the things we've added based on a direct request from customers. Another thing that also came at a customer request and some other work we were doing, in seam weld analysis, when you're using forces and moments, we've added an extra option. So typically the seam weld method was derived from a stress-based method initially, from Nastran with stress cubic results from linear elements. So that was the initial method. That was then added to be able to, for other FE codes, to either use second order stresses directly or to use force moment input. The initial method when using force moment only did a weld normal at the weld toe. So it took the forces from that particular element, calculated what the weld normal was, and used that directly. We've now added a shear option. So if you get an extra option in the setup for the job, and you can now pick to use the shear stress as well. So then it will pick the shear stress up along this weld toe as well as the normal stress. So that allows you then to use average max principle and critical plane to look at the effect of both of those components. So in this example, where you've just got a torsional load applied to this component, you would pick very little damage up with the force method before the shear was added. Now you get a much better result at looking at the shear force as well as the norm. So add a little bit more capability to the force moment option. So it takes into account the shear stress component for the force-based seam weld calculation. Now, one of the things we've done over the last few years is do quite a lot of work on the vibration side, the vibration load provider. We've added that now covers SN, EN, seam weld, spot weld, and short fiber composite engines, so you can use the vibration method with all of those. The one thing we've added in this release is to add the multi-PSD loading ability to seam weld. So that was the only thing that wasn't available in seam weld when you've got multiple PSD inputs. We've also done quite a bit of work on the two main methods in the calculation that go from the PSD to stress results. We've done work in both the exact method and the fast method. Quite a lot of work to optimize the speed in the exact method. So that now is the default option you'll find from 2019 onwards, because it is now pretty much the same speed as the original method. So we've got then gives more exact results for all the for average max principle, for example. We've also done some work in the fast method while we were doing that to look at making that a bit more accurate. So the results for that have changed slightly as well in this method. But as I say, the now exact is now the default. So if you do a new calculation from scratch with a new glyph, that method will be used. If you pull your old flows back in, we will use the method that you selected before. So it will still generate the same method as you'd already got set in your flow. So that gives a more accurate and faster calculation of the resolved stresses from vibration loading. And that covers most of that's pretty much the end of the major changes in vibration loading to extend that to all of the different solver types within DesignLife. One thing to mention as well while I'm on this, those results have changed slightly in those methods because of the change we've made. There's also some very slight changes in all the results for DesignLife because we've moved to the latest compilers in generating the software. So the very, very small results changes in mainly Windows applications, but very, very small. But just mention that while we're going through. We've also added full general support now to PAMCrash's PAMCrash ESI group's PAMCrash format, the ERFH5 file. So this is now generally supported. There's not all options available at the moment. Where there's some extra functionality going into PAMCrash, so we can add some extra results types that we use in DesignLife. So currently, Spot Weld is waiting for their 2019 version to come out, which we're doing work on at the moment. So that should be in the mid-year release. Seam Weld's not currently supported because we can't, from forces is not supported, so we can't get the forces out at the moment. And modal transient, modal vibration not supported because there's no way of extracting the participation factors at the moment. We're looking at doing that in the future. And currently composite elements not supported. Again, that's a continued expansion of our support for different file formats, and that's an ongoing activity to keep our support up to date and to add new file formats where appropriate. Next thing to mention is some new materials in the Premium Materials database. So you may or may not know the Premium Materials database is an extra database we supply that is licensed to users of the token system for our licensing. So it's available to all those users. Currently over 100 material datasets in that database. As Fred mentioned at the beginning, there's quite a lot of research activities going on in additive manufacturing materials at the moment, and in line with that, we've done quite a bit of testing over the last year, and 5 of those new additive manufacturing materials have been added to the Premium Materials database at this release. So that's basically looking at different manufacturing methods, surface treatments, load, direction, and material orientation for those different materials. So they're all titanium alloys with, as you can see on the screen, they're different surface treatments, giving slightly different fatigue performance for those nominally similar materials. So that's a set of strain life fatigue properties for additive manufactured titanium alloys, and we'll be looking at adding more of those in the future and continuing to add more materials to the Premium Materials database.